Tighten your seatbelt. This runway is made of ice. Welcome to the Ruth Glacier, deep inside Alaska's Denali National Park. Some come for a photo op. Others for backcountry skiing. But this is no vacation for University of Maine paleoclimatologist Carl Kreutz and his team. For them, time on the ice is all part of the job.
All right, so sample 2 should come from a depth of 50 centimeters, please.
With support from the National Science Foundation, Kreutz and company are working to reconstruct the climate history of this area over the last 1,000 years.
So what we're interested in doing is looking at the relationship between temperature and precipitation rate and the response of glaciers in this area to those changes.
In 2013, the team drilled ice cores high atop Denali's Mount Hunter. By carefully analyzing ice layers inside the cores, the team has come up with a record of temperature change in the Alaska Range over the last millennium.
But what we think we see so far is an increase in the rate of melting in the past several decades. So from roughly 1930 to today, it seems like it looked like there was more melt layers or warmer summers in those few decades than the time prior to that.
This tracks with what scientists have observed in recent years. Most of the world's mountain glaciers, including nearly all in Alaska, are retreating. The vast majority of glacier ice on our planet lies in Greenland and Antarctica. And so it should come as no surprise that's where most of the attention and scientific effort is. But the people who come to the mountains and the glaciers here say the ice here shouldn't be overlooked. Assuming the melting trend continues, and Kreutz thinks it will, these alpine glaciers will make a significant contribution to global sea level rise in the coming decades.
The estimate now is something on the order of 1 meter of sea level rise is locked up as ice in mountain and valley glacier systems.
This season, the team turned its focus to the Ruth. Geophysicist Seth Campbell is using ground-penetrating radar to direct pulses of energy down through the ice to map its depth. Until now, scientists have had to do a lot of guesswork as to how much ice is here.
A lot of these glaciers, we don't really have a good estimate of total ice volume. We don't have an estimate of total ice depth, and there's give or take 60 to 100,000 glaciers in Alaska. Of that, maybe 10 have been studied significantly.
The team also uses snow pits and radar to estimate the prior year's winter snow accumulation. They dig through the previous year's deposit of snow to take samples for study and validate the radar data.
But by digging a pit and seeing, in fact, how much snow has fallen this past year and comparing the actual observation to the radar signal, we can have more confidence.
The more time spent on the ice, the more that confidence level rises. And this team is all about getting the facts nailed down cold. For Science Nation, I'm Miles O'Brien.